we'll be looking at exactly what it is. We'll get to understand the whole concepts and the frameworks that are used in machine learning to be able to see exactly what it is required for an individual to be able to talk or get to learn about machine learning. So with that much said now, I will get to dive into it and get to learn about machine learning. And we'll be able to see that machine learning is a subset of artificial intelligence. That is a very key word to be able to understand or be able to note that it is a subset of artificial intelligence, which now focuses on teaching computers to learn from data and improve over time without explicit programming. So what does it mean? Now the insights and patterns that are composed, that are entailed in data, that are used by algorithms in machine learning to learn and understand exactly how each or what to understand for that. This makes now the machine learning or the algorithms to be able to learn and be able to perform some tasks from the insights and patterns that it has understood from the data set that we've given it. So that is what means we don't have to explicitly give that if maybe an example of that if it's less than 5, uh, then do this, okay? Then perform a specific task. You don't have to explicitly program for the model to be able to perform. So there is no case or there's no way that it will be able to have to be explicitly programmed for that to perform. In machine learning, it uses the insight that it learns from the data to be able to perform tasks. Okay, so if you give it a task involving maybe a sales trend, it will be able to understand from the sales trend regarding on the dependent variables that you have used, can be able to forecast or be able to predict how the sales will be for the next period of time. That is what we mean by machine learning. So for this case, we'll have to use data, train our models for machine learning aspect to occur. So there are different types of machine learning, which now we start by the first one is supervised learning. Supervised learning is a full scope. This supervised learning, it is where now we get to use let me delete that and get to talk about supervised learning. It is where now we'll be using rainbow data set. Rainbow data set. This rainbow data set is where now you've already labeled the data set for the algorithm to understand. This is where now we use data set that comprises of input and output data set, where you get to give an input to the model and the model will learn from those particular insights to be able to understand. So the whole aspect of machine learning, it is where now we'll be using data. Just to recap on that, and this particular data is put in a model. And then from the model it gives us an output. This is the input as a regard for this particular concept. So when we talk about now labeled supervised learning, this data set that we are using in this particular case, it is labeled, where you get to have data with labels for the input as well as for the output. So the models will be able to learn that from this particular data, we get to learn these labels represent these values, and these values are supposed to you get this insight from the values for you to be able to anticipate or give the output of this particular regard. That is what we mean by supervised learning. So when we talk about unsupervised learning, it is where now we have unlabeled data set. And in this particular case, we just give data without regarding which particular data, where does it come from, and it doesn't have labels. So the model itself is what is supposed to identify the patterns and similarities between the data that you have provided. And then it will be able to cluster or be able to classify different data according to their similarities to different clusters or to different groups. That is what we mean in unsupervised learning. The data is not labeled data set. So the model itself able to understand and get to extract relevant information from the data set. This is by now getting to understand the models, or getting to understand the patterns that are involved in that particular concept. We talk about reinforced learning. When we talk about reinforced learning in this particular case, it is the aspect where now the model learns by reward and penalties as it goes by. So whenever a model exercises or practices a certain action, it is rewarded if it's right. So it gets to understand that if it do a specific task in this particular manner, it is rewarded, meaning it is correct. And if it does it in a different manner, it is wrong. So it is penalized. That makes out the model itself to learn by itself how to get it better and better and better. These include now the AlphaGo game, where now if you train a computer and play with the computer several games, it will be able to learn from those particular several games that in these particular games it is learning from these particular games that every move it makes, whether it was penalized or it was rewarded. So with that, whenever it repeats the same game again, it will remember that in certain position, I moved the beans into this particular case and I was penalized. So it decides not to move it in that particular direction and moves it in a different direction and tries to make more sense in that particular data. And whenever it is rewarded, now it marks that as a move, and it will be able to utilize it more and more. So as many times as it learns, as many times as it gets trained, it will get collecting more information, correcting more information, and that makes it more better and better and better in that particular case. That is what we mean for this particular case. That is what we mean in this particular case. So that is what those are the three types of machine learning, where we'll get to look at them one by one for that particular case. Now, where do these particular machine learning models applied? What are the application cases of them? This is where we include now like fraud detection. When it comes to fraud detection, maybe in banks or other areas, you get to see that it gets to understand that with it, and it be able to see exactly what it means for that particular case. Okay, you get to understand exactly what's supposed to be in that particular case. So these particular applications of it, they include now issues like fraud detection. This is where to get to understand that whenever there is a specific pattern that it's carried out in a particular transactions. So if it gets to understand that maybe the transactions got to much higher, they get to circle and get to raise an alarm or some and abnormal operations. That is where now it gets to understand that there was subnormal operations that happened in this particular case. And that's why you get to detect fraud detection cases in maybe bank systems. We talk about natural language processing. This is where we can talk about chatbots in cases where now you can get to have a self-service or a customer service that replies to your customers from the interface, and that gives it more better clarity in any point given. Then we talk about financial firms. Yeah, it's used also in financial firms, where now it gets to understand, maybe it can get to give a trend of transactions or sales or anything to do with stock changes, maybe the stock exchange plans, and can be able to give a prediction or get to show whether what is expected in the near future. Then in healthcare, it's also used in healthcare when it comes to diagnosis. It's also another aspect of concern that is used when it comes to this. And this is where it gets to use maybe for cell diagnosis, diagnostics applications. This is where now to get to look at maybe some cells that have been trained with healthy cells and unhealthy cells. So whenever now a patient is brought into that particular machine and is specimens, all these cells are extracted and then they are being fed onto the particular model, it can be able to distinguish whether there is underlying conditions or not. Then we can talk about autonomous systems. This is where we have even the automatic motor vehicles, where you get this, they are driverless and they get to drive. This is by training the model that it should use or should follow a specific line. It should look at objects on the load, what should happen on that particular object, what are the load signs, what should it say, and that particular way by default. The image and speech recognition. This is also another application when it comes to machine learning. So you can get to train a model with an image or a speech, and then it can be used to use. It can be reused several times, maybe even for when it comes to these particular applications. Recommender system. Anytime an individual, maybe let's say in an e-commerce website or in a maybe Netflix, when an individual gets to watch a lot of information that are related, the models gets to classify or get to analyze that particular historical data, and then it looks for other related searches that are related to the previous searches of that particular individual, and it gets now to recommend to that particular user more or other several applications in that particular case. So those are the different applications of machine learning. Those just but to mention, there are way more other when it comes to this particular application cases. So data science framework for machine learning. So we want to understand the frameworks of this particular machine learning and how does it happen and what are the flow of training the models and getting to reuse that particular model, as well as making the model more better and more understandable. So with that particular case, this is where we get to problem definition. So at any point given, you will need to have that particular problem defined cases for that particular case to happen. This is where now you need to have the objective. You have to, what are the set goals that you want to extract in this particular case? What do you want to get or what do you want to achieve in your problem statement for that particular case? So this is what we mean by objectives or goals. Objectives or goals. And this will even give you to define exactly what do you want to do. What kind of machine learning task are you aiming to establish? This is where you can talk about classification learning, or it is a regression learning, or it is a clustering learning case of that. So it is important to understand the problem and to understand the requirement of this particular problem for you to be able to choose the right tools and techniques for this particular problem. Then we can talk about data collection and preparation. This is another important and crucial step when it comes to machine learning. This is the aspect where you are supposed to gather required information in regard to the problem statement, to the object that you had set already according to your project. This is where you can gather relevant information. This is from maybe databases or any other source that you like to. Then you are supposed to clean that particular data by even pre-processing that particular data. These include issues like handling missing values or issues of outliers or inconsistencies from that particular data. Then you can be able to transform the data into now a suitable form that you'll be able to use for to train your algorithms. So those are particular aspects of concern that comes with these particular cases of frameworks of data science. Then we talk about exploratory data analysis. Exploratory data analysis is also another aspect of concern that is a very crucial aspect and a very crucial way of dealing with. So analyzing this particular data using now techniques like descriptive statistics, visualizing data using different techniques, you can be able to gain insights, identify patterns or trends in that particular data. For you to be able to understand now the relationship between these particular variables and how rich is your data into relation to how you want to train it, or to relation to how you want to give it to your model. This will help you even to other cases like now making decisions and even about issues of feature selection or engineering, the aspect of you want to create more data from the existing data for your model to be more informed. or else in cases of you want to select the most relevant and the most important features for you to use to train your model. That helps you much. Also, even the cases of now, you want to maybe to select the best model that comes with exploratory. This is where you have realized what kind of data you are dealing with, what insight have you gained, so you can be able to decide on, I want to deal with a specific selection of models. That is what we mean for this particular case. Then we can talk about cases of feature selection engineering. This is the most other important of it. Now you have already gained a whole scope of the data. You understand each and every data. You understand each and every aspect of it. And then now you can be able to predict the most important features. Then you can be able to use it now for any maybe aspect of predictive power of the model, because aspect of feature selection is the aspect where now you are supposed to select the most relevant and important features to train your model with. So that will help you in most cases. And these particular cases will be crucial for now whenever you want to reduce aspect of irrelevant or noise data, as well as now feature engineering. It is the aspect of creating more or existing data from the more data from the existing data. These might include issues like modification, customization, or manipulation of the existing fields to give more extractive data. An example include a birth date. Whenever you have a birth date, it might not be so much informative as when you extract the age of the individual from the birth date. That is the aspect of what we talk about. And these types of feature selection and engineering, it is very crucial when it comes to reducing the aspect of model complexity and even improving the generation of that particular model. So the model at least will get to understand the exact thing or the exact information that is required for this particular case. Let's talk about data splitting. Data splitting, it is the aspect of now dividing or sharing the data into different sets or different subsets. This is where now we can talk about, we'll like to split this particular data, the data that we'll train with. Then you have then create another subset, which is for testing the model after you have trained it. And some cases, you might need even to have other databases or other subsets, which include validation subset. Validation subset in this particular case, it is where now we are talking about the case where this particular data has been wants to validate as it trains. It wants to keep validating to understand whether it's understanding the patterns and the insights that have been done with. So splitting the data into training or validation data and also the test data will help to ensure that the model is trained, it is tuned, and even evaluated on separate proportions of the particular data to help now the data to prevent issues like overfitting or underfitting or unbiased estimate of that particular model. So in short, this will help you to evaluate the performance of your model at any point given. That is what we mean by data splitting. So we can talk about model selection and training. So whenever you have already done this, you already realized the problem statement of what you want to achieve. You also into the idea of understanding exactly what other issues that you might be going through. And now you want to know this particular data is suitable for a specific model. So this will help you now to the aspect of you choosing the appropriate machine learning algorithm based on the problem type and the data set that you've already analyzed earlier on. This will help you even now to get to understand which models can you use and how many can you interact with for that particular case. That is what we mean by model selection. We can talk about model validation and tuning. So when we talk about model validation and tuning in this particular case, it is the aspect where we evaluate the model's performance on the validation set using appropriate matrices. So this is the aspect of where now we want to validate our model. We have already trained our model. We want to evaluate the best performance of this particular model, as well as validate it whether it's reliable model or not. So in this particular case, this particular step of model validation and tuning will help us now to ensure that the model is well tuned in respect to the problem statement that we had outlined earlier on, and then we can optimize the model to the specific problem that we are dealing with for that particular case. Talking about model testing and evaluation, this is also another aspect of concern, which is important in these particular cases. This is where now we need to assess the final model's performance. We need to know how better the model is performing, because at the end of the day, for this model to be reliable, for this model to be applied, it has to be good performing. So we have to assess the final model performance of the test using now the test data that we had separated earlier on in this particular case. This is what will be used to evaluate the model or to test our model in the aspect of getting to know how much reliable is the model that we are dealing with. So in this particular case, we get to see that there are a few other issues that come along with these particular cases. So we can talk about model deployment for our case. So model deployment is another stage which is very important. Now we have already recognized that our model is performing well and the model is doing well in the aspect of concern that the model is growing, the model has a good performance, the model is a reliable model to work with. So with that particular case, we can get to see that now we can be able to utilize this particular model and deploy it for usability by other people. So this is where now model comes in. Now we are supposed to deploy this particular trained model to a production environment such as cloud platform or an API, or even integrate it with the web application or a mobile app or other system that can provide real-world value at this particular case. That is what we mean by this particular case. So let's talk about model monitoring and maintenance. Now, having that we have already deployed our model, we doesn't have to stop from there and don't just move on to this particular case. At any point given, we will have to keep checking on the performance of this particular model. We will have to keep updating it with the upgraded softwares, upgraded codes, and even maintaining that particular model. So there is a continuous monitor of the model performance in production, because at the end of the day, we want to see how efficient, what percent did it meet to the agreed problem statement. So with this particular point, we can even keep updating it with the new data, retraining the models for it to enhance the accuracy, and as well as the model to remain relevant for that particular case. So when we follow this data science framework for machine learning, we can be able to systematically develop and deploy effective machine learning models that will be able to address real-world problems and deliver value. That is what we mean for this particular case. That is what we definitely get to see in this particular system of application. Okay, so that is necessarily what is required in these particular cases of time. Now, let's talk about problem definition. Now we're going to look at a individual clauses one by one. And when we talk about problem definition, when we get to define our problem statement that we want to deal with, we get to understand what technique will we use. Will it be regression? Will it be classification? Will it be clustering? What exactly problem we'll be using for this particular case? As well as now we'll be able to see that whether it's whether it's a time series project that we're supposed to work, whether it's a reinforcement task that we're supposed to work. This is the aspect of now when we talk about this particular case. In regard to the problem statement, we can be able to identify that our data that we want to predict, if it's a matter of predicting, will it be a continuous values or not? And this is where now the aspect of regression comes in. Regression is the aspect of predicting continuous target variable for this particular case. Will we be classifying in our model, will we be predicting categorical variables? This is include issues like what we have seen earlier on, like fraud detection. This is what we talk about, categorical variables. So for this particular case, we include issues like spam detection, image recognition, customer churn prediction, and etc. So this is the aspect of it. So when we get to define our problem statement, we'll get to see that our issues that regard to this particular case, it is our objective lies with, we want a continuous prediction. Maybe it's a matter of house prices. So let's assume it was a matter of house prices. This will be a continuous prediction, house prices. House prices. When we talk about classification, maybe we want to know whether customers will they churn or will not churn in a bank. Okay, so this is what we mean by classification. We want to understand from our problem definition, we'll be able to categorically decide or be able to know what we really need in that particular point. Same case for clustering. Clustering is where now we get to cluster different data points into with regard with their similarities. This is where we can maybe talk about customer segmentation. We want to segment customers according to their similarities. Or else we can talk about dimensional other issues like anomaly detection. This is where now we can get to look at outliers where there is abnormal behaviors in terms of clustering. So we can be able to classify the normal behavior and abnormal so as we can be able to detect and classify and be able to point out that particular point. Other cases include clustering, document clustering. These are also areas of it. So maybe other cases that might be in regard to our problem statement, maybe it's a time series task or it's an enforcement task that we want to undertake. So at least now with a clear goal of what we want to get from this particular task, we can be able to understand, we can be able to see exactly how we'll be able to work around our statements. So this is where now we get to outline objectives and how should these objectives be like. So like for our case, we should have a clear outline of the problem that we want to solve. We should specify the scope and limitations of the project. These are different aspects of concern that we are supposed to deal with. We can also identify the stakeholders and their requirements. These will guide us on exactly what we are supposed to work with. Establish a timeline for the project. These will include the milestone and deliverables. This will help you to be able to lay down your strategy in the best way, in the best manner possible. Then we can talk about determining the resources needed. We have already seen that whenever. So our objective will be clear. You'll have a clear understanding of the goal that you are looking forward to, and that will help you to particular that. So with that case now, you will even have what we call evaluation metric. Evaluation metrics is the aspect of where now you want to gauge, you want to evaluate the performance of your model, or how will you be able to gauge whether your model is performing best, is performing well. These are the cases of what we talk about. So if it's a case of regression, we have different evaluation metrics, which include a mean absolute error, we have a mean squared error, we have root mean squared error, and we have R squared. These are different types of evaluation metrics that we'll be looking individually. Then when we talk about classification metrics, we have accuracy measure. We can be able to get precision. We can get to look at recall as well as F1 score, area under curve for that particular cases. So this is what we mean by classification matrices for this particular case. Okay, so these are the areas of concern. These are the areas of understanding that an individual is supposed to get. So this will be able now to help us to gauge the performance of our models. Talking about clustering metrics. Clustering metrics also, an evaluation metrics is silhouette score. Silhouette score is used to evaluate the performance of that particular model. And that is what we mean for this particular point. So we'll be in a good position to be able now to evaluate. We'll be able to know how will our model be performing. in regard to the evaluation metrics, and we'll be able to set a goal of how better do we want our model to be for that particular case. For you to be able to come up with the idea of how reliable is the model, you need to have an evaluation metrics, which in this case, it is different particular evaluation metrics in regard to this particular model or task that you decided as an individual earlier on. That is what we mean for this particular case. That is what we necessarily mean when we talk about these particular cases. So when we keep in mind all these issues, we'll be in a very good position now to even get to the next step of now the aspect of data correction and preparation. So we will need this at the end of the day. We want to prepare data. We want to have to correct that particular data now, having in the back of our mind, we have the objectives and we have how to measure the project or the outcome of what we are looking at. So with that particular stage, we'll have not much time, or we'll not be in a position that will lead us to be confused or even not get to understand the specific data. Now we'll get to data sources. There are many types of data sources out there, which include databases, include APIs. You can be able to use APIs to gather data. We can talk about web scraping. This also, web scraping is another way of getting data. We have open data repositories. These will include like UCI, machine learning. You can talk about the Google public data sets. They are there. You can use a lot of data set that you can in regard or in accordance to your project. Even you can just undertake surveys to be able to record the data that you want. That is necessarily on to you as an individual to be able to see and be able to understand exactly. So when we talk about issues like databases, these include MySQL, this can be include non-SQL databases. When we talk about APIs, this can be able to maybe from social media, maybe other aspect of it, or maybe weather services or financial institutions. Those are different aspects of concern. So then after we have corrected this particular data, now from the sources, we need to clean that particular data. And when we talk about cleaning data, it is where now we check for various issues like missing values. We want to know, is there missing values in our data? This is where we have to handle missing values, because we can never get to deal with a dirty or a messy data. That is where we get to look and we can impute the missing values using methods like maybe median imputation, forward and backward filling, or other techniques that are more advanced like k-nearest neighbors or regression imputation. That is the aspect of what we are dealing with. It's in accordance to the objectives and the idea of the project that we are looking forward to. We can look at other issues include inconsistencies. Inconsistencies where we get to see that our data maybe has duplicate errors, duplicate records, or even incorrect data types, or even inconsistent formatting of that particular data. Because if we need a data, we need to look at the data formats, we need to look at the data styling, and each and every aspect of it. Other issues include outliers. This we get to understand which are the different aspects of outliers are there. And this we can be able to handle outliers using different methods. Okay, like interquartile rule is an Z-score and turkey fences are different aspects of handling these particular outliers in this particular case. Okay, so these are different aspects of it. So when we talk about data preprocessing for this particular case, this is another aspect of it. Now we have data, we have already cleaned that particular data. Now we are in the pre-processing aspect of concern. This is where now we may need to have a data that has of the same scale. This is where we can use normalization. Normalization is where now we scale features to a common range, where maybe it's between, which is 0 and 1, for that particular data to be relevant, because we might use data that comprises a column of age and a column of salary. The salary values are already high. If we use data of column of salary, it means that that particular data, the model might assume the salary column is more relevant than the age column, whereas it's just the aspect of the value numbers. So that's where we get to the aspect of normalization. All another way, it is the aspect of standardization. This is still also where now we can get to use other method or other technique based on the mean should be 0 and a standard deviation should be 1 for that particular case. So there are a few methods that can be used in this particular case, which include z-score standardization, and this can help now the aspect of having that the model will not be biased at any point given. So we can talk about transformation. Transformation is still another aspect of concern that is very important and vital when it comes to data preprocessing. These include encoding the data. So whenever we have data, that is, we can convert categorical feature into numerical format for that particular case. This is actually to specify or to note. Whenever we are training our model, we always train our model using numerical data. So when we talk about transformation, transformation might include techniques like encoding. Encoding is the aspect where we convert categorical data to numerical data, because that's the only way we can get to use that. And this is where now we can talk about aspects like one-hot encoding or label encoding or even target encoding. There are different aspects of concern, but we can talk about that when it comes to aspect of encoding in the aspect of data transformation. We can talk about other aspect of maybe you want to use ROG. ROG will be able to have a general data or be able to identify that particular data of that particular case. And we delete that and be able to change it. So when we talk about transformation, it might include aspect like encoding. Then we can talk about aspect like feature transformations. So maybe say also aspect of handling imbalanced data. Imbalanced data for that particular case. So these are different aspects of it. So whenever maybe you have a data that lies more on one side than the other, because if you want to show cases of fraud, you need to give enough information about fraud cases and that are not fraud cases for the model to be able to understand and get to learn exactly how the data will be utilized. So those are different aspects of it when it comes to data preprocessing aspect of concern. So we can talk about other aspects which include exploratory data analysis. We already seen that. So after you've already now prepared and processed your data in the best way possible, there are other features like descriptive analysis that we're supposed to do to get to understand the mean of a certain variable, the median. You get to look for mode, aspect of variance. This is the dispersion degree of your data, other aspect of skewness of the data to be able to understand how much reliable is your data. Then with the aspect of gaining more insight and patterns, this is where you get to the aspect of issues like data visualization. So this is where you can use features like histogram to visualize your data. You can use data like bar plots. Okay, you can use bar plots. You can use histograms. You can use scatter plots. This will help you to be able to understand, or this will help you to be able to see exactly what is it that you are dealing with. This will help you to be able to see or be able to know that what are the underlying insight and patterns that you maybe never captured when you are doing your data preprocessing. So this is what we talk about visualization. So we can use histogram. We have seen what is when it comes to the aspect of data distribution. When we talk about scatter plot, this is the aspect of visualizing two continuous data. We already seen that earlier on. We talk about bar plots. This is where we can visualize categorical columns according to their quantity value. We can talk about box plots. These are visualization of distribution and giving descriptive statistics information in regard to that particular variable that we are visualizing. The other include other visuals like a heat map. other visuals like heat map for this particular case. Then we can talk about pair plots. Other visuals like pair plots. So these are different aspects of visuals that you can undertake whenever you are doing your exploratory data analysis to be able to understand more about that particular data or more about that particular data you are dealing with. These are, you will be able to get a lot of information from that particular case. You will be able to see a lot of relevant information, because whenever now you identify a trend, the relationship between that particular data, you'll get to acknowledge issues like, let's talk about correlation, maybe outliers that you never noticed in your data cleaning, maybe other issues of trend. You can be able to see how the patterns are. Are they seasonality trends? Are they cyclical patterns? Or are they increasing trend over time or not? Are issues of that particular point? How do these particular variables interact with each other, so that you can even get to see from the heat map, you can get to understand the correlation between that particular data aspect of it. So in one or the other, EDA is very essential step when it comes to machine learning processes, because it will help you to gain a deeper understanding of the data, uncover insights that you might not have captured earlier on. And this will also even give you a strength and confidence for you to be able to make some informed decisions when it comes to feature selection. This is where you want to select a specific feature. When it comes to data visualization, when it comes to pattern identification, this will help you out of the EDA that you have undertaken in that particular data. So talking about feature selection and engineering, this is another crucial part when it comes to the machine learning processes. And this particular case, it is where now you want to specify the feature importance and selection method. When we talk about that, you might use a correlation aspect of concern to be able to show it with you, and you can be able to get feature importance. Feature importance is the aspect of where now you get to identify the most relevant variables to use, and there are different methods that you can get to identify using that particular piece. Issues like correlation. This will measure the linear relationship between each value, and can be able to get the target variable to identify using that particular variable to be able to see exactly what are we dealing with. So when we talk about feature importance, it is the aspect of establishing which are the best or which are the most useful variables in your data. And now, with regard to the target variable that you are dealing with or the output feature, you can be able to identify which variables or which fields or which columns to say do you use to train your model. Okay, we can talk about issues like mutual information. This is where you quantify the dependency between those particular features. Also, how do these particular features depend on each other? This will help you to be able to gain and gather how better the models or the features are in relation to the target variable that you are looking for to training of that particular case. So this is what we mean by all that. There are different methods that are involved, which include recursive feature elimination, RFE. There are new features that can be used to be able to identify or to be able to eliminate different features to understand and deal with for that particular case. We can talk about other features include like tree-based models to be able to use the most aspect of it. So this is what we mean for that particular case. When we talk about now the other aspect, which is feature engineering, we have seen what is feature engineering. It is the aspect of using existing features to manipulate, to create more features that are more relevant or with more relevant information, or manipulating the existing columns to better give you information. Now, an example is where you have a unit price as well as the quantity of the items bought. You can get to know sales of that particular. You can create another feature by the name sales, trying to identify how did you get to that. So you can be able to create another feature by the name sales. So we can talk about sales. And sales will be derived by unit price. unit price multiplied by the quantity ordered. So at any point, the quantity ordered will give you a sales column for that particular case. So this will help you even to gather more irrelevant information for that particular statement. And there are different techniques that can be used, which include now the aspect of transformation. We have already seen. We can use even aspect of maybe data. We want to look to get a log of data, log of a specific variable to be able to have data understanding of that. Or maybe we want to get that particular data by using square root or power to address the issues like skewness when it comes to this particular aspect. So if your data is skewed, you can get to use some techniques to be able to reduce and be able to tackle that particular aspect of it. This also, it is with the aim of trying to improve the model performance. Okay, so this is the aspect of it. Other aspect might include when we get aspect of aggregations, like we have seen, you can get to look of statistical summaries of different variables, or even group data into different groups for any or for more relevant insight from that particular data. We can have, there are more of information when we talk about that. When we talk about feature engineering, it is an aspect of gaining more insight from the data. Then let's talk about dimensionality reduction. Dimensionality reduction, it is the aspect of reducing the variables or getting the most relevant variables. This is the aspect of now trying to reduce from a high dimension to a lower dimension data for you to be able to maybe to retain the most significant, maybe to reduce the computational cost or to reduce to avoid overfitting aspect of concern, or even to reduce the memory usage in that particular for that particular model. So there are a few techniques that are involved when it comes when we talk about information about dimensional reduction. This is which when we call about PCA. PCA is one of the techniques that is used when it comes to dimensionality reduction. We can talk about TCNE. TCNE, it is the T-distributed stochastic neighbor embedding for that particular case. This is also another technique that is used for that particular case. Other techniques include LDA, linear discriminant analysis, LDA. This is also another way that is used for that particular case. Then we can talk about autoencoders. This is a type of neural network learning where now you get to use a lower dimensional representation of the input data to be able to encode that particular data. So those are different techniques of it, feature selection and engineering. We have seen feature importance and selection methods, which we call it that they are methods that are used to select the most important features to use to train your model. We have seen about feature engineering. This is the aspect of technique that you can use to create more relevant features or manipulate the existing features to give more relevant information. Then we have talked about dimensionality reduction. This is the aspect where now transforming data from a high level dimension to a low level dimension. This is the aspect with the aspect or with the aspect of retaining the most significant information of that particular data. So it is not entirely about transforming from high dimensional to a lower dimensional only. It is even with the aspect of retaining significant information in that particular data. So that is what we necessarily mean in this particular case of concern when we talk about feature selection and feature engineering. So as much as we are dealing with preparation of how to train all the flow chain of modeling in data science in this particular case, we can talk about now the other framework that is most relevant in this particular case. And this relevant in this particular case, it's now data splitting. We have already talked about data splitting. This is the training set is used to train the machine learning model. So we get to split the data into a subset of, now this is our data. then it's now you split it to several data sets. So for this particular case, you might have train and a test. So what happens in this particular case, when we talk about train dataset and trace dataset, it is now the train dataset is used to train our algorithm, our models. And then the test dataset, it is used to test the performance of our dataset, of our model in that particular case. So after training our model, we should use, or we can use our training, our test dataset, which is unseen dataset. They doesn't have the aspect of maybe, they doesn't have now the target variables. It is used to test now the model to be able to know how better the model is performing. So in that particular case, we can talk about train and test dataset. For this case now, if at any point you might need to use, and what happens is that you might split it 80 to 20 or 70 to 30, 70 to that with that particular case. So at any point, if it is applicable, you might need a validation data set. So you can get to split another slice here for validation data set. So this validation data set is where now there is a iteration of training in your model. And this particular model, as it is trained, as it loops down more and more, it gets now to understand that it might need to know whether did it really perform better. With the validation dataset, it used now to get to understand whether the regulation of the weights and biases, the constant biases, whether they'll be relevant or they'll be adjusted to what level for that particular case. So this is what we mean by data splitting. So at any point given, before we train our model, we need to split our model, our data into train and test dataset. The train dataset will be used to train the model, and the test dataset will be used to test the existing, now the trained model. How better will the model perform? Okay, that is what we mean for this particular case. So talking about cross validation. Cross validation is also another important method of now assessing the model performance and then reducing the aspect of overfitting and underfitting in this particular case. So what do we mean by cross validation? Cross validation, it is the aspect where now we split data into several subsections. And this particular case, you get to see. And with this now, you use this data to test our model. Then we train again the model using the same set of data. But in this particular case, we use this particular one to test our model. So this is trying to enhance the performance of the model, and especially not getting even to reduce the aspect of overfitting from the model, because now we will not train the model using this particular data. Unlike the area alone, we have trained it using it. So we'll use it to test. Same case, we can get to train again this particular model into this particular case, and then use this to test the performance of the model. That is what we mean for this particular case. That is what we exactly mean when it comes to these particular cases of concern. Okay, so this the aspect of data on the aspect of cross validation. It is the aspect of using different subsets to test the model and train the model for the model not to climb or get to master a certain pattern. So with this case, when you keep dropping different subsets, it will enhance, or it will need the model to keep pushing, or the model to keep upgrading or keep learning from the new data set that is been used to fed in this particular case. That is what we mean by cross validation. Okay, so the aspect of data splitting, it is very crucial in this particular process of machine learning, because now it will be able to, it will help you to allow, it help you to evaluate the model performance as you have seen, as well as now, even when it comes to cross validation also, will help to have you be able to understand the assessment, the reliability assessment of your data for that particular case. Okay, that is what we mean for this particular case. So let's talk about modeling. Now we have already trained our model. We have cross-validated it in different subsets to be able to have a very efficient and very clear model. So with that particular case now, we get into modeling. This is where we train an algorithm using now the prepared data to learn the insight and patterns, as we had seen earlier on. Okay, and with that particular case, we can talk about a different aspect of concern now. There are different models that are algorithms that you can guess to train. These include logistic regression, they include linear regression. We can talk about decision tree. There is a random forest, neural network, and support vector machines. So these are different types of models that can be used to train the algorithm using the data and can be used now to make predictions or make even those particular cases. So this is what we mean by modeling for this particular case. So we'll be using, you can use either or in regard now, in respect to your project, to a problem statement. You can get to identify which one do according to your task. You can get to identify which one is there. Because if you talk about logistic regression, this will be for classification methods. Linear regression will be for continuous methods. We'll be talking about different aspects of it to be able to narrow down or to be able to specify to exactly what is it that you are dealing with. That is what we mean for that particular case. So after you have trained your model, the model is not yet ready to be able to be put there. So we can talk about hyperparameter tuning. Hyperparameter tuning, it is the aspect of tuning the parameters that have been involved in training the model for the model to be optimized to better performance. Okay, that is what we mean for this particular case. And hyperparameter tuning can include now an exhaustive search of different combination of parameters to give the best combination or configuration that can give or yield the best model for that particular case. That is what we include, or that is what we call grid search. The aspect of exhaustively searching between every combination of the model, every type of combination of this particular model to be able to talk about. So when we talk about grid search, we mean that particular case. Then there is another aspect of it which we call random search. Random search is also another way randomly combining different parameters to be able to see which gives the best automation for that particular case. So that is what we mean by random search. Then there is Bayesian optimization. This is also another way of hyperparameter tuning. This is a probabilistic model-based where now you get to use the prior information and get to understand which is the optimal parameters that can be effectively be used in that particular model for achievement. There are very many other issues, very many other techniques that can be used when it talks about this. They include genetic algorithms, they include particle swarm optimization, they include simulated annealing. There are quite a lot of them. So it's a matter of you as an individual to decide on which one to deal with. And that is what we mean. So there are many, or they can be able to highlight different practices that include when it comes to this particular aspect of training this particular model. How do you get to make sure that your model is performing best, that your model is reliable? This is by other features like feature scaling, which you already seen when we are talking about preparation of the data. We can talk about regularization. This is the aspect of regularizing now the data. And we can talk about different techniques that can be used like lasso, ridge, or elastic net. These are different aspects of it We can talk about array stopping. This is the aspect of where now you can train your model, and whenever you notice that your model has started overfitting or it's not improving anymore, that is what you get to understand that you need to reduce or you need to stop training the model. Either the model has reduced its performance or it's stagnant, it is not learning more. That is what we call by array stopping. We can talk about data augmentation. This is the aspect of where now you can create, we have seen this in feature engineering, the aspect of creating new information to use to train our model for the model to perform better. Then there is model ensembling, combining multiple models in this particular case to improve the overall performance and reduce overfitting of that particular model. So these are different particular aspect of concern that is required in this particular case. With that particular case, I guess now those are different. So these are different aspects of concern. These are different techniques that are used when we talk about this particular case. These different techniques are used to be able to enhance or to make your model perform better. So we can talk about other aspect of concern. Let's see model validation and tuning. So when we talk about this particular framework, it is performance evaluation of that particular model. And we can talk about issues like confusion matrix, where now we can use the actual data. So if the actual data was 0 and it was predicted to be 0, this is what we call the true value for that particular case, the true negative for this case. Then if the actual value was 0 and the predicted was 1, which means that is a false positive. The positive was a false. This is the aspect of confusion matrix into evaluation. These are evaluation matrices that are used in modeling aspect of it. So if the actual value was 1 and the predicted value was 0, this gives us a false negative because the negative that has been predicted is false. And if it's 1 and was predicted, it's cause a true positive for this particular case. That is what we mean in model validation and tuning for this particular case of study. Then we can talk about other issues like let's say LOC. This is LOC or AUC for this particular case. These are different aspects of concern. These are different ways that you can get to see or evaluate. These are just evaluation matrices that are used to be able to evaluate the performance of that particular model. So that is what we mean for that particular case. So for this particular LOC, it is the receiver operating characteristic. I mean, this is where now you get to plot into relation of the true positive that we have seen, the true positive and then the false positive for that particular case. And this is where we get to see that the more this is 0, this is 1, and you find that maybe this is when. So the more the model is performing better, the better the model is performing, the more this curve tends towards to this particular point. So that is how we get to evaluate and see how much the better it's performing. So the positivity of it is what it means. And we talk about area under curve. This is the AUC. AUC is the area under curve. This is the area that is in this particular, that has been segment that has been surrounded by the receiving operator characteristics for this particular case. So these are different evaluation matrices that can be used. There are the evaluation matrices that include precision, like we had mentioned earlier on. Precision, let me just correct on that particular name. Precision. Then we can talk about F1 score. F1 score, okay. Other various or other include MSC, There are very many evaluation metrics can be used. There is other MAE. These are different evaluation metrics that are used when it comes to model validation and aspect of it, an aspect of tuning. So there are different techniques that we have already seen, like regularization. So now we have evaluated the performance of the metric earlier on. And we have seen that in this particular case, the performance of our metric of our model is not really good because maybe we are aiming at 95% accuracy and it's giving us maybe 84%. So for us to transit from 84 to 95%, this is where now we get to the aspect of tuning, the model tuning aspect of it, which includes aspects like techniques like regularization. Regularization is the aspect now we get to apply a penalty in that particular data to improve. And this technique, they might include lasso, they might include ledge and elastic net. So these are different aspects of technique when it comes to regularization of this particular point. This is where now we try to avoid to reduce the overfitting of the model, and as well as now try to improve the generalization of that particular model. This is now we get to see the loss function is a bit, so maybe we wanted it to be predicting 4.5 and it's predicting 3.9. So we want to reduce the gap between 4.5 and 3.9. This will help us now to be able to understand exactly how that particular data differs for that particular case. That is what we mean by regularization for any case given. Then we can talk about other issues like ensemble methods. And there are ensemble methods where we combine multiple models to improve the overall performance and reduce overfitting cases. And this is where we can use techniques like bagging, we can use techniques like boosting, or even techniques like stacking for that particular case. Then we have hyperparameter tuning. We already seen that in the aspect of grid search, random search, and Bayesian optimization. So these are different aspects of it that we can get to use and we can get to deal with at any point given in our data set. So let's get to understand what is overfitting and underfitting for this particular case. It's supposed to be underfitting, overfitting, and underfitting. So let's get to see what is the difference between that. Underfitting. So whenever you use data to train your model and the model does not capture the insights or the patterns in that particular data. Now, if you look at this particular illustration, that the model has noticed that it is a linear, straight curve for this particular case. This particular data, you can see, this is our model. Model has assumed that it is a strain, there's a strain curve in this particular case. But as you can see, the model now fails to capture the underlying structure of the data and performs poorly when it comes to evaluating how did it learn and when it comes even to test data set for that particular case. In regard now, in comparison to the balance now running for this case, you get to see that the model has learned, the model has captured the sequence or the situation of how the data patterns are. Now, talking about overfitting. Overfitting in this particular case, it is where now the data does not understand the patterns or the insight regarded to this particular data. Okay? This means that it's only a data that was used in this particular overfitting aspect of it. So now you get to see that now it has captured each and every point. Now, whenever you give unseen data, it will perform poorly. This is where now in overfitting, you might find it's performing poorly in trained data set, poorly, and as well as in test data set is poorly. But in overfitting, the trained data set, it's performing perfectly. But in test data set, It's performing well. That is what we mean in that particular case. So whenever your model is performing well, it means that it didn't capture the patterns, the underlying patterns in that particular data. It never captured that. So it has to, whenever you give it unseen data set, it will not perform well. That is what we mean by model overfitting and underfitting. So let us look at other steps that are included when it comes to this particular aspect of it, or maybe to look at, or maybe to just highlight on few aspects of it. This particular aspect of overfitting and underfitting, how can we get to regulate it? How can we get to solve it? So if it's a matter of case of overfitting, to be able to address this particular, we can use simpler models in the aspect of overfitting. Our remedies can be simpler models. Then we can talk about issues like reducing the number of features, as well as maybe all increasing the aspect of trying to increase the number of training data that we are using, try to get that particular point. And this is where we also get to accommodate the aspect of cross validation technique. If it is a matter of underfitting, where now the model is performing poorly on both sides, these on both cases, it means maybe we can use a more complex model, or let's say more complex model, because maybe it's not learning the data is complex, so it needs a complex model to be able to see or be able to gather the underlying. So let me delete that and get to complex model. We have other issues like maybe we would like to look at we engineer the features to be able to make the features more reliable for that particular case. So that is what we mean in that particular cases. So now regarding other issues like other steps include model testing and evaluation. We'll need to do this at the end of the day. We'll need to really do this for us to be able to achieve the best of it. So after selecting, after hyperparameter tuning, after evaluating this particular point, we can get to see maybe we are dealing with different models. Maybe we are dealing with random forest and maybe SVM. And now we see after all the issues or after all the processes, we can get to understand and get to see which is the best model to rely on in this particular case. This is how we get to understand. We can use any performance, any evaluation metrics, just with the aim of getting to understand exactly what is required for us to be able to do that particular case. So when we talk about model evaluation and testing, this is where now we evaluate and get to see that particular case. This will regard even to analyze how best the performance of the conclusion in regard to a problem statement. Then we can talk about model deployment. This is the aspect of now deploying our model in the crowd for other people to use it or for public use. This is why we can be able to deploy them to Google Cloud, maybe AI. We can use other platforms like Amazon SageMaker. We can use Microsoft Azure ML. We can use IBM Watson. These all provide scalable infrastructure where you can be able to integrate and build into model for that particular aspect of it. Unless it can be an API, you can be able to customize or create an API for your machine learning model to be able to enable a seamless integration with other application services. That is particular part of it. Then we can talk about model monitoring and maintenance. Model monitoring and maintenance in this particular case, it is the aspect of now you have to continue checking or tracking the performance of your model every day. This will be able to help you to be able to have accurate results and even be able to make that your model keep on being updated day in, day out. This will help the model to perform better or improve at any point given. Okay, So that is the full scope of machine learning, from data correction to monitoring and monitoring and maintenance of the model, to be able to have a working model and a model that meets the individual's performance or the individual expectations